We already know that transportation is a sustainability problem. This is from the EIA, just projecting the vehicle miles traveled. I'll use that acronym quite a bit in this presentation. VMT is projected to increase substantially through the next few decades. And the emissions, the environmental impact from this transportation is also set to increase. Because of that, the transportation sector is responsible for over 30%, about 34% of that, of the greenhouse gas emissions that are consumed in the United States. So we know it's a problem. We are doing a good job of identifying that we need to decarbonize transportation, but we're not doing a good job of getting people out of their cars. So that's what this is kind of looking at. I did a case study of the Phoenix metropolitan area, and from this point forward, when I say Phoenix, I am going to mean the entire metropolitan area, 27 cities, 3 Native American nations, municipalities, towns, villages, all that combined. And when I talk about the sustainable transportation or the sustainability problem, I'm really talking about the environmental impacts from the environmental sustainability. Andrew Fraser in our lab came up with this methodology because there is no data on when the roads were built. All the transportation agencies care about is what roads do we have now. So what we did is took the building age as a proxy for when the roads were deployed and worked off of that to inventory over time the deployment of the roadway infrastructure. And so this is Phoenix. Really, it's a young city. The data is pretty available because of its youth, and it grew. You're seeing the 1950s here, the 60s. It really grew in the post-World War II era and started to really sprawl from there. More than half of the road network has been deployed since the mid-1970s. More than half since the mid-1970s. So it's really young, and you can see those lighter colors towards the outside. That's really the fringe, the sprawling Phoenix, low-density, single-family homes, big neighborhoods. These bold lines here are the highways, and we have the major interstates running through, but we also have the highway loops. So they're called the 101, the 202, and the 303. So this is what I'm kind of defining as the urban core, even though the planners in Phoenix would say that that's a very liberal definition of the urban core, because really the city of Phoenix is just right in here. The road infrastructure, again, it has really grown since the 1950s, and so we've done this inventory, and I'll kind of orient you to the methodology that I'm using for overlaying an institutional analysis with a life cycle assessment. So if we look at transportation planning and travel, it really, this is a adaptation from Mannheim 1979, which is classic transportation planning paper. We see that the vehicle travel and the roadway planning is at this nexus between the activity system and the infrastructure that you have. And the travel happens because of this interaction, and so does the roadway planning. Because you have people traveling, you have a need to do the transportation planning. My hypothesis for my research was that path dependence is the issue here. We have this this automobile path dependence in the way that we do infrastructure planning and land use planning. And so this is definitely going on in Phoenix, and there's a bunch of literature on lock-in and path dependence. And so I'm really going to be focusing on how to break that path dependence, or that automatic thing that happens when you kind of look backwards and you realize we could have made better decisions, and what made us make those wrong or worse decisions in the past, and how can we break that path into the future. So one way to do this, to look at breaking path dependence, is in sustainability transitions research, and there's a lot of literature on that as well. But what we have to do is understand the current state, and it's a complex system. We have to understand the current state and understand where that current state is going, so this BAU path, the business as usual. And then look at how do we even define what we want. That's very important because sometimes we don't even know where we want to go. We just know we don't want to go there. So we have to define this future state and then work backwards from there to say what points along the way in that business as usual path, who, what, when, where, who has to do what, who's responsible for it, what do they even have the capacity to do, what do they have the authority to change, and then where are those, and we call those intervention points to make this transition to a different path. And so this is what, LCA can give us this and maybe this quantitatively, but getting to who needs to know and who has the authority along the way, that's what is has been the gap in applying the insights from LCA. So really quick, these were the steps in my research. I did a retrospective LCA, so I looked at Phoenix from 1950 to now, inventoried all the impacts from the passenger transportation, the roads, and the vehicles and the vehicle travel from 1950 to now, and then did an institutional analysis of the transportation planning system, then projected forward to future trajectories for the LCA, did a prospective analysis of different trajectories of how we could deploy roadways in the future, and then overlaid them into what we're calling the IALCA, Institutional Analysis Life Cycle Assessment, to look at what are these transitions, what do we have to do to intervene to get on these new trajectories to do something different than the business as usual path. So this is my system boundary diagram for the life cycle assessment. I assessed all of the raw material extraction, energy consumption, and emissions from the automobile manufacturing, the use of those automobiles, so what we typically call tailpipe emissions, the gasoline production, so refining, blending, and transporting the fuels, and then the road construction itself, so building the actual road. And then after the road is built, you have series of surface repavings and complete reconstructions of those roadways over time. I can answer questions about which tools I used and which data inputs if you're interested in that. But basically that's the systems. And then all of these energy consumption and air emissions along the way are defined in phases and inventory to get these quantitative results. And I did costing as well. So just to orient you, the public spending I'm defining as spending on roadways, so road construction, road reconstruction. The private spending is the spending on purchasing automobiles and purchasing gasoline. So you can see the relationship here relative to each other. Little bit of public spending enables all of this private spending over time. So this is just Phoenix, 1950 to now, 61,000 lane miles of roadway, 4.8 million automobiles just for Phoenix, 39 billion gallons of gasoline consumed. Same picture for the energy consumption and greenhouse gas emissions. This is energy. You see I'm keeping the same color scheme, orange for roads, blues for the vehicle phases. And you see little bit of road construction infrastructure enables a whole lot of automobile use. 6.6 exajoules cumulative of energy consumption, 1950 to now for Phoenix. That's a lot of energy. And so looking at the institutional analysis, if you're not familiar with institutional analysis, it is a social sciences framework. And a framework, is just a lens to view the system. So you're defining how things work, who does what. These institutions, when I say institution, it's not a physical institution. It can be visible. It can be a building. It can be an infrastructure. It can be a person. But an institution can also be invisible. It can be a rule. It can be a norm. It can just be the way things are done. And so really when you do institutional analysis, you're just trying to figure out how the system works, who does what responsibilities they have. And then it can give you insights of the application of your quantitative results. I'm not going to bore you with all of this. The big deal is transportation planning in the Phoenix metropolitan area is very complicated. There are a lot of people There are a lot of organizations, there are documents, framework studies, regulations, and all of this is happening at the Metropolitan Planning Organization to build roads and make decisions about how to deploy roads. So looking forward, our future trajectories, we can do business as usual. We can do a plateau where we take the current planning out to about the next decade and a half, 2030 or so. But then we can really do a concerted effort to densify and do transit-oriented development in the markets that we've developed. There's some studies that support this kind of idea. Then our integrated transportation and land use trajectory takes this idea of TOD infill and makes it happen earlier in like within the next decade. And then that we figured out that's not enough. It doesn't get us very far. So we had to go very aggressive and do all of this immediate transit-oriented development, immediate infill, immediate deployment of new transit infrastructure, and then also institute some market forces, some economic, putting a price on carbon, increasing the gasoline tax over what it is now to deter the driving and this induced effect. Basically, in these scenarios, we're looking at changes in VMT and changes in the number of roads that we deploy. So you can see by the color scheme, we just have different levels of VMT and roadway deployment for these scenarios. And even though, like say in the plateau scenario, we stop building new roads around 2030, so this does plateau, but the population continues to increase. So every new person that moves to Phoenix is going to drive a little bit. And so we don't see the VMTs plateau, and that's an effect of the population increasing, but it is less than the business as usual still. So looking at the LCA results, we get varying degrees of reductions. So you can see this sustainable Phoenix trajectory is that lowest green line. And the reason that it's spiky, if you're wondering, why my scenarios are so smooth but the results are spiky, this is because of the roadway construction. Once you build a mile of roadway, you have to maintain it indefinitely. So there are cycles of the roadway reconstruction that still has to happen because we have to maintain the current system. So we have energy here, greenhouse gases here, human health respiratory potential. These are using the Tracy, the EPA's Tracy impact assessment, and then potential smog forming emissions here. Same story, little bit of infrastructure impacts, a lot of use and behavior VMT impacts. So I'll just give you a little taste. Like these are the transition strategies that we recommended for each of the scenarios, plateau, ITLU, and sustainable Phoenix. For example, one of them for plateau scenario is that the member agencies of the Metropolitan Planning Organization, they need to integrate their framework studies for sustainable transportation. They need to integrate them into future planning efforts. They need to do that in the next few decades, by the 2030s or so. And this is just one of a suite of things that they need to do to make this trajectory happen. For the ITLU scenario, these framework studies need to assess life cycle benefits and costs in their scenarios that they consider in the studies. And they need to do that pretty much now. And then the big one for the Sustainable Phoenix trajectory is that the state government would have to be involved in instituting this gasoline tax, right? That's huge. That's not easy, but it's one of the things that has to happen for that scenario. So when we look at this is the crux of all the research. We can overlay these institutions, these numbers that now show up on this system boundary diagram. The squares are just indirect effects. The circles are where we have direct authority or direct effects in any of these processes. And you'll kind of notice there are no direct transition strategies that occur in the phases where a majority of the impacts are happening. You can't tell people, well, we haven't told people that you can't drive, right? Not in the US anyway. But we do have some direct effects in the road construction, and we have an awful lot of direct effects in roadway planning, right? So this is the big idea. So these, I'm not going to go through each one of these, but just to give you an idea, it's a whole suite of transitions, and you can't disaggregate any of these and say, if the Fed does emissions reporting in MAP 21 or whatever, then you get this much of a greenhouse gas savings. You can't disaggregate it, but you can say, look, if we do all these things, it requires attitude changes, education at all the levels, at the Fed, at the state, at even the citizen level. But if we do these, we can get ourselves onto this path where we enable it, we make it possible to get this new trajectory. And there's transitions for each of the scenarios. For sustainable Phoenix, we would need the Fed to put a price on carbon. That's huge. We would need to expand ideas for alternative fuel vehicles, and facilitate an awful lot of behavior changes even at the city level and the citizen level. What is possible by 2050 if we do this, though? Here's a close-up of the greenhouse gas emissions for these scenarios. If we start doing TOD infill, transit-oriented development infill, by the 2030s, we can put ourselves on this plateau track, and we can reduce the greenhouse gas, or avoid is a better word, avoid about 21 million metric tons in the Phoenix metropolitan area. If instead we do that earlier, we start doing infill by 2018 or within the next decade, we can avoid 53 million metric tons of greenhouse gas emissions. But what happens here, you can see where this number 3 is. At some point, the population growth itself kind of overrides these savings that we're getting, and then it stops. And then you can see if we do it earlier with very aggressive stuff, then we can get all of these savings through here. So that's the gist of it, and I have a couple of other slides about why this matters, but the bottom line is it can give LCA context. It can fill that gap where we have these results, we have these comprehensive things, we can't communicate them to who needs to know, who has to do what, who even has the authority. Phoenix can't manipulate how Detroit makes cars, but we can recognize that, and we can do things in other ways to have these indirect impacts on the systems and what goes forward.